21st day of machine learning and you have reached the last day of this event. So, very much congratulations from Code Warriors as you have learned various things from us throughout this event. I wish you to use all information and knowledge which you got from this event in your work and all the very best for your future dealings. Now, what you have learned so far. So, in this journey, you have learned about supervised learning and its main types, which are regression and classification. You have learned lot of different algorithms for regression and classification and implemented it in your code using scikit-learn library. You have got some basic information about these algorithms and implemented various projects for both regression as well as classification. Now, what's the difference between regression and classification? So, the main difference between regression and classification is that regression deals with continuous or we can say numerical values and classification deals with categorical or we can say discrete values. So, regression predictive modeling is the task of approximating a mapping function from input variables to a continuous output variable. A continuous output variable is a real value, such as an integer or floating point value. These are often quantities such as amounts and sizes. For example, a house may be predicted to sell for a specific dollar value, perhaps in the range of $1 lakh to $2 lakh. Classification predictive modeling is the task of approximating a mapping function from input variables to discrete output variables. The output variables are often called labels or categories. The mapping function predicts the class or category for a given observation. For example, an email sent to you can be classified as belonging to one of two classes, spam and not spam. In classification, deals with one or more discrete labels and regression deals with continuous quantity. Now what next? So you are going to have an overview on unsupervised learning, which is having subcategories clustering and association. And the second one is reinforcement learning.
Now we are going to take a look about these concepts one by one so that we will have a basic understanding about them. First is clustering. What is clustering? Right? Now the thing is, clustering is a type of unsupervised learning because in this we do have data points but we don't have any labels or output for those data points. The main purpose of the clustering is to process the data to find meaningful structure between them, find or extract some features out of it, like the properties or attributes about those data points. Now, you can just think that the clustering is kind of a task, or I mean, just kind of a way to divide all the data points into various number of groups from each other. And in these groups, each group will contain those data points who have same similarity, or I mean who have same attributes or traits compared to other groups, right? I mean, if there are two data points in the same cluster, they are most likely that they both the data points do have same attribute. And if the data points are in different cluster, they are not much related, or they don't have much similar attributes from each other. Now you can think, what is the use of clustering when we don't know what will be the output, when we don't know what is the use of it and like that. Now clustering is I mean kind of very important nowadays. What I mean, let me give you an example of how clustering can be used. It can be used for marketing. Like suppose a mall wants to target some specific audience, or I mean some specific customers by their advertisements of something like, let's just say, for sale and like, and they know that the customer who are much regular to the mall, and also the customer who does have more spending score, I mean they spend more compared to other customers, and they know that for on these ads, or I mean on this sale or in these marketing stuffs, the people who are regular for the mall or have much more spending score are the persons, or I mean are the customers who are going to take action on it. So that's why they want to, I mean, target only those specific customers. So the clustering can be used in this by taking first the data points of all the customers, and then we will try to split the data points on the basis of their spending score and their regularity for the mall. And once they are divided into the cluster with the data points of customers who have more spending score and more regularity to the mall, are much more likely to be the audience which the mall needs to target. So they are going to target only those specific audience. And that was just a basic example. The clustering can be used in a complex way by dividing the customers, or I mean dividing the group of customers into on the basis of their age and on the basis of their purchase history and like that, right? I mean it can be used in a very complex ways also. And as you can see in this image, the first image where it shows that all the data points are here, and when we perform a clustering algorithm on it, they will be divided into certain different clusters, like here cluster 1, cluster 2, and cluster 3, on the basis of input features, like here which will be their x1 and x2, right? But the clusters are not going to are not always going to be in a specific shape like circle, square, or like that. They will be non-regular shape also. As you can see in this image, the shape of these two clusters is non-regular. I mean it's not a specific shape, right? So that was about clustering. So our next concept that we are going to see is association. Now association is also a part of machine learning and a type of unsupervised learning. In this, what the algorithm does is try to find relation between various variables and data between each other, right? I mean, it tries to find a degree of similarity between them, similar to the cluster, but it's a little difference, and it always try to find the hidden relation between data points. I mean, you can understand it quite well just by, I mean, understanding the definition. So let me give you an example, right? Let me give an example of Amazon products recommendation. They check all the users history, that which user purchased this, and after that when what the user purchased, and they kind of use association learning to figure out that what the users mostly purchase after a specific product. Let's say a person purchases a laptop, then they're most likely most of the users after purchasing laptop also purchase mouse, and in this way they use it and recommend certain products after the purchase of a specific product by user. And that's how they create recommendation engine, right? Using association, associativity between those products. And also an example of Google search autocomplete. I mean when we try to search something on the Google, it also gives us a auto generated recommendation like, are you trying to search this or to search this or search this. There are various examples we get, and that was also a type of using an association learning there. Now a best example of it is about a Walmart, where Walmart hired some data analysts, and after what they did is they find out that the people who most likely buy milk also buy cereal with around 80% confidence. And here 80% confidence refers that most of the people who buy milk, after them 80% also buy cereal, right? And similarly, they also figured out that the people who buy bread are most likely the person who are going to buy jam. So what Walmart did is they placed the shelf of jam just near to the breads, and it led the increase in rate of selling of jam by 60%, right? And that was all about association, where it tries to figure out or tries to find out the hidden relation, or I mean the relation between various data points. And in this example, our data points were the products. You can also see in this image where we have a list of items that it contains, and also certain transactions like bread, milk, bread, diaper, beer, eggs, and like that. And in this example, our model figure out from the transaction that the people who buy bread also buy milk, and the people who buy milk also buy diaper. In this way, the association model work. The third that comes reinforcement learning. What is reinforcement learning? Reinforcement learning is also a type of machine learning. I mean, in which we train a model to make specific decisions on its own. In this, we make the agent to achieve a certain goal in a specific environment, or I mean a complex environment, where we make the model to make its decision by its own, like trial and error method, in which it have to come up with a solution. And how it does is that the model will be given to take action, and on the basis of action the model will be given a reward or a penalty. If the model make a good decision, it will be rewarded, and if the model make a bad action, it will be punished by a penalty. In this way, the model is trained to make a decision in such a way that it will gain maximum reward as possible. And that's how a reinforcement learning works. I mean, before the first, when the reinforcement learning came up into place, there was only basic where it was only rewarded when it takes a specific action correct. But after that, in the advancement of reinforcement learning, they've implemented penalty system also, where it will be penalized when it takes a bad decision, right? I mean, it's just like a game of maze where we teach an AI how to solve a maze, or I mean, so that it will learn by its own that where to go or where to not. And nowadays, the advancement of reinforcement learning is much more that it's kind of getting used more and more in the field of game development also, where I mean, the most big companies in the game industry, they created their own NPCs, or I mean, non-player character using AI by using of reinforcement learning, where they learn to take action by their own, right? I mean, if you play games, you also know that nowadays the AI that the game use are kind of most advanced, like they cover and shoot and also do other stuff, right? And that's, I mean, that's what the, and that shows the advancement in the reinforcement learning. As you can see in this image, the agent, that is the model, it will check the environment and take action on its own. Now, after the action, it will interpret the situation, current situation, and it will try to figure out the state of its own. If the model figure out that it took the good decision, it will be rewarded. And in this way, it will learn by its own, by trial and error method, again and again and again, to attain state, so that it will take decision on its own with a maximum reward as possible.
Hello everyone. So in this last section of today's video, I will familiarize you all with the deployment of an ML web application on the Heroku cloud platform. It's an awesome platform for students who are starter in this ML domain and want to deploy their models and learn the deployment process and how to deploy the models. So Heroku platform provides you free deployments of the ML models or any kinds of websites or applications that you want to deploy on the internet so that it can be globally available to others. And Heroku provides you 5 web application that you can develop that you can deploy on Heroku platform on one account. So if you are new to the Heroku platform, then you have to make your account first, and if you already know about it, then it's good. I already have one account here, so I'm using this account only. As you can see, I have deployed some models also. So today I will going to show you a brief demo of how to deploy an ML web application. So before deploying our model, I want you to know the files that are required, important files that are required for the deployments of a Python web application. Since we are using Flask here, so it's a Python web application. So the first file that we require here is the proc file. So the naming convention of this file should be exactly similar to this, in which the first letter P should be capitalized and the rest should be in small letters, and there is no extension of this file. So in this file you have to first specify your type of application. Since this is a web application, we will write here web, then colon, then we are using here Gunicon app, which is a Python package. So this is a Gunicon app, so you will write Gunicon space app colon, then you have to specify the application file. I will see you which file I'm talking about. So you can see here the app.py, which contain the Flask code of our web application. So you have to specify the name of your file which contains the web application code, and then you have to save this file. And the next file, which is requirement file, requirements.txt. So in this file you have to specify all the requirements that you need, such as Gunicon, then Flask with their proper version, then scikit-learn and pickle-share. That I have used these four libraries in this, so I have to specify the requirements of this application, and its name also should be just like it, requirements.txt. The name should be correct, otherwise you will get an error. And the last file is runtime.txt. Its naming convention should also be exactly same like I have written here, runtime.txt. And in this you have to specify the Python version which you are going to use. So these are the three necessary files that you require for your Python web application to properly deploy on the Heroku cloud platform. So, and this is the GitHub repo, and I'm using GitHub as a uh, content provider in the Heroku. I will explain it later how the GitHub is used here. So first we have to make a new app. So I will click on this new button and create a new app. Then you have to provide the name of your app, and it should be unique. So I'm using car. This is a car price prediction application, so I'm writing here car price predictor CW. So now it's a unique name, and then I will create the app. After creating the app, it will ask you the deployment method. There are three types of method you can use. Heroku Git, which is used as you can use with CLI also, how you can deploy your files from your local system to this here Heroku cloud. And if you already had your files in the GitHub, then it is very much easy to deploy in from the GitHub, because its UI is very easy to use. So just you have to sign in your GitHub account here, and then you have to choose the repo that you want to connect here. So the repo name is car price predictor, so I just write the starting characters. Now you can see the whole repo name is shown here, and you just have to click on the connect button. After connecting, the repo is now connected with the Heroku, and there is this button also, enable automatic deploy. When you click this button, then whenever you change the code in the GitHub, the app will automatically deploy here, and the changes that you made recently will also be shown in your app in the real time. So it's a good feature, so I will enable this button. After that, you just have to click deploy branch, and it will start deploying your model from your GitHub to the Heroku platform. So you can see here it installing the Python 3.7.7, which I have specified in the runtime file, and then it will install some basic libraries, and the requirement library in the files, the libraries which I have specified in the requirement file. You can see here Gunicon, then Flask, and it's successfully installed. And now this compressing step is very much important, because in free account Heroku allows you to make an web application which comes in the size of 500 MB. If your app reaches the size more than 500 MB, then your app cannot be deployed in the Heroku on free account. If you have purchased the pro account, then you can deploy any different size of apps that you want. So it's launching our app. After successfully build, we can see here a button which says your app is finished. So you can see your app was successfully deployed and view. So now we can view our app. So you can see this app is now globally available. You can anywhere write this URL and you can see this app running. So let's test this app. So first it's asking the year of purchase. So I will write 2017. Then kilometer driven 10,000. Fuel type petrol. Transmission manual. And let's see what's the price. It's 4,90,000. So it's working. Let's take some other readings like 2018. Kilometer driven is 20,000. Fuel type is diesel. Transmission is manual, and predict. So you can see the price has increased. So this the model is working fine. So I hope you understand how this deployment is work, and if you have any doubts, then you can also see the documentations here in the Heroku platform. There are documentation available for every language. Suppose you have a Node.js app, then you can see the their documentation how to deploy their models. We are using Python here, so you can see the Python, and there are other links also getting started on Heroku with Python. We have used this deploying Python application with Gunicon, so you can click on this link and see all the steps how to deploy these apps. So I hope you cleared your doubts. So thank you for listening me, and I hope you enjoyed this session. This is our last video of 21 days of ML, and if you have any doubt you can ask me on the LinkedIn. All the best, guys.